All right, so continuing to review for test number 2. We're on number 15. 15 is that problem that's talking about the toy rocket. And when you shoot off a toy rocket, what's going to happen is it's going to leave the ground. It's going to go up, and then it's going to come back down. Okay, so it's going to give us a function that goes along with this. Okay, what we're trying to do is we're going to need to find the vertex of this upside down parabola. The x coordinate of the vertex is going to be how many seconds it takes to reach that height. And the y is going to be how high is its maximum. Okay, and it gives us the function where we can find that vertex. It says h of t equals -16 t squared plus 112 t plus 4. Okay, and it's going to ask us to, so what we're going to need to do is use this function to find this vertex so we can see how long it takes and how high it goes. So the x coordinate of the vertex, we'll use the opposite of b over 2a. So the opposite of this b is -112 over 2 times a. A is -16. So now I've got -112 over -32. Which gives me 3.5. So that's going to be the seconds. Now let's use this number to find the y, which is going to be the height. So let's see if I plug it in, or I guess the t. So if I plug it in, -16 times 3.5 squared plus 112 times 3.5 plus 4. Okay, and then you'll just plug this into your calculator. So -16, open parentheses, 3.5, close, squared, plus 112, open parentheses, 3.5, close, plus 4. And what do you get when you hit enter? 200. Okay, so again, that answers the question about how many seconds it takes to reach its maximum. And that's the maximum height. Sorry. No, you're good. Number 16. This gives us a square root function and asks us to find its domain. So what do we need to be concerned about with what's underneath that square root? It needs to always be positive. Good. So another way to say that would be greater than or equal to 0. So that's what all you're going to do when you're finding the domain of a square root function. So f of x equals the square root of 4x minus 7. So what's underneath here, which is that 4x minus 7, needs to be greater than or equal to 0. So that's how you're going to set it up, and then just isolate that x. So here I'll need to add 7. So I've got 4x is greater than or equal to 7, and then divide that by the 4. So x is greater than or equal to 7/4. All right, number 17. It's going to be another square root function, and it's going to ask us to graph it. And if you'll remember your shifting rules, the four different options in A, B, C, or D, the square root function is just shifted up, down, left, or right. Okay, we've got f of x equals the square root of x minus 7. So this is an inside shift, right? Since it's inside that square root, what does the inside shift do? It shifts you left, right, opposite the sign. So where is a minus 7 going to shift you? Good. To the right, 7. Now, the scale is going to be 5 on this one, right? Because there's 4 hash marks and you're at 20. So 5, 10, 15, 20. So shifting it to the right 7 is just going to be a little past that first, or in between the first and second hash marks. Okay, again, the other options are just going to have it shift up 7, left 7, or down 7. Now, number 18 is a little trickier because of the B and the D options look so similar, but I'm going to try and give you hints on how to determine between those. Hopefully the one on your test won't be they won't have two options as similar to each other. Okay, number 18. G of x equals the square root of 8x minus 1. So first of all, let's look at and see what its domain is, which would be where the square root's going to start. That'll tell us that. So what's inside? Needs to be greater than or equal to 0. Add the 1. So 8x greater than or equal to 1 and divide it by 8. So x is going to be greater than or equal to 1/8, which is where the graph is going to start on the x at 1/8. And this scale, this is the one where the y scale is going by 1s, but the x scale is going by 2s, which is going to make this look a little different than what it would look like in your calculator. If I'm starting, this is telling you where the square root's starting at 1/8, which is, just barely to the right of the origin. Okay, I'm going to go and I want a couple more points. Okay, so I'm going to actually put this in my y equals. So second square root 8x minus 1, and then graph it. And again, it's going to look a little different than what you would graph because of the scale being different in the x and the y. So let's go to the table. So if I go to table, you'll notice that 0 is where the error starts, right? Because it can't be 0. Where it starts is going to be 1/8, a little bit to the right of 0. So it doesn't give me any good whole number points. Like when an x is 1, y is 2.6458. When x is 2, it's 3.873. And we'll do, let's see, x is 3. 4.7958. Okay, so we're just going to get close here. So when x is 1, which that's 2, right? Since these go by 2, so it's actually right here, up 2.6. So these go by 1. So there's 1, 2, and around close to 2.5. Again, we're just getting close here, right? Because these numbers are so crazy. To the right 2, which is actually the first hash mark, up 3.873. So up to almost 4, maybe a little below 4. So this gives us the general idea of what this shape is going to look like. Unfortunately, if you have the handout, if you're looking at the difference between B and D, which is what you're going to be choosing from, they're so similar, right? But on this one, you can, next to each of those graphs in Math Lab, there's going to be a magnifying glass, okay? And it looks like, if you magnify that, let me make sure I don't get it wrong. Yeah, it looks like D actually starts at 0 or maybe even a little bit left of it. Okay, so they look very similar. So when you magnify it, you'll be able to tell which one starts a little bit to the right. Okay, and hopefully there's a good chance that you're not going to have two graphs that are so similar to each other. Okay, because it's just random. Okay. 19. So again, I suggest finding where it starts and then coming up with some points using the correct scale for your X and your Y. So you'll see that it's steeper than what it looks like in your calculator. Okay. Number 19. Number 19 is when we've got to the piecewise functions. And this one has 3 pieces, depending on where you are on the graph. So f of x equals x squared for when x is less than -2, x minus 2 for -2 is less than or equal to x, which is less than 4. And the last piece is 5x for when x is greater than or equal to 4. It wants me to find what piece f of -2 is in. So if I'm looking, I do see that -2 is actually in 2 pieces, which means what are you looking for? The equal to bar, right? If this is in 2 pieces, you're looking, this says x is less than -2. Well, it's not. X equals -2. So which piece would you be plugging it into? Good. X minus 2. Okay. Doesn't ask us to plug it in yet. It just asks us what piece it goes in. Number 20 is going to give me the graph of a piecewise function and ask us where it's increasing, decreasing, and constant. So let me draw it out. Okay, so here's the graph of a piecewise function. Now remember, the first thing we did on these is go through and label what is occurring on each piece, whether it's increasing, decreasing, or constant. So what's happening here? What are the values doing? Good, they're going up. So they are increasing until it gets to this point. And what's happening on this piece? Good, decrease. What about this straight across? Constant. Increase again. And straight across or constant again. Now, remember when you're talking about increase and decreasing, everybody has parentheses, and we're always using the x coordinate in the places where it's changing direction. So let's go through. It's going to start at negative infinity. What's this one's x? It lines up with -7. This one's x lines up with -5. This one's x is -2. And this one's x, the last one is -1, and then to infinity. So it wants increase, decrease, and then constant. So the increase is going to be 2 separate intervals, right? This one and this one. It says use a comma if you have more than one interval that you're typing in, use a comma to separate them. So what's the first interval going to be? Negative infinity to -7, good. Comma. The other increase is -2 to -1. The decrease function, we've already labeled it, so we're essentially just going and writing these two numbers. It starts to decrease at -7 and it decreases until -5. And then the constant interval. I guess I should say intervals, right? There's 2 of them, starting here at -5 to -2. Comma, the last piece is -1 to infinity. That's 20, 21. All right, it gives us a function, f of x equals -x² plus 5x minus 1. It would be an upside down parabola since the x² is negative, but then it gives us all the information that we're going to need. It tells us that the vertex is at 2.5, 5.25. The first question is, does this function have a relative maximum or relative minimum? Where's the vertex? It's at the top, which means that's its maximum. Good. Then it says the maximum occurs at x equals blank and has a value of blank. What is the x of the maximum? 2.5. And what's the value? The value is always talking about your y coordinate. So the value of this maximum is 5.25. And then it asks you, so where is it increasing and decreasing? This left side of the vertex, the values are going up. So there's your increase. Once it hits the maximum, it starts to fall. It starts at negative infinity and ends at positive infinity. So where is the increase from? Negative infinity, what am I using? Always increase and decrease is the x. So negative infinity to 2.5, which is also where it starts to do what? Decrease, right? Once it hits its maximum, it's going to go down. So it starts decreasing at 2.5 to positive infinity. right? 22. I shouldn't even put hash marks. I'm just gonna draw it out. It tells me what the points are that I need. This one's at -8, -1. And this one's at -2, -19. Okay, so this one is going to ask me where the max or relative max and min are, but it kind of, the difference between this one and the last one is this one, the last one, it said the maximum occurs at x equals blank and has a value of blank. So they're asking it backwards, but just remember the maximum value is always your y, and then it's going to actually tell you where to put the x, right? Because it's going to say x equals. Okay, so what is the relative maximum value? -1, and it occurs at x equals -8. The relative minimum value is -19, and it occurs at x equals -2. And then we'll do our increase and decrease intervals. Where it is, so this is increase. That little piece right there is your decrease, and then you're increasing again. Again, it goes from -infinity to +infinity. So the first increase is -infinity to good, -8, because you always use the x. So -infinity to -8. And where does this increase start? -2 to infinity. And where is it decreasing? It's only decreasing on this one little piece. So from -8 to -2. All right, 23 is another piecewise function, and it's going to ask us which piece the number goes in, and then it's going to ask us to actually plug it into that piece. So one step further than that last piecewise function that we were looking at, this time the function is h of x equals -2x minus 17 for when x is less than -7, 3 for -7 is less than or equal to x, which is less than 3, and x plus 7 for when x is greater than or equal to 3. It's going to want us to find 4 different values. The first one is going to be h of -9. Then h of 1, h of 3, and h of 7. So again, we're going to find what piece it goes in and then actually use it to plug in that piece. So -9 on the number line is -9 less than -7? Yeah, because it's more negative, right? Which means it's less than. So I'm using this piece, -2x minus 17. And then I actually plug it into that x. So if I do that, I have -2 times, plug in -9 minus 17. So -2 times -9 is 18 minus 17, which is 1. You need a pen? You have another? Oh. So h of 1, which piece does 1 go in? It's not less than -7. Right, it goes in between -7 and +3. What is the answer for every number that's in this piece? 3. It is just 3. There's no x to plug in. What would that look like if I actually drew out this piecewise function? What do you think's happening between -7 and 3? It's constant. They're all 3. They all have a y value of 3. h of 3. I see 3 in both, or 2 of them, which means look for the equal to bar, which means it goes in this x plus 7 piece, and replace its x with 3. So I'll have 3 plus 7, which gives me 10. And then my last one, h of 7. 7 is greater than 3, so it also goes in this piece, x plus 7. Replace your x with 7. So 7 plus 7 gives me 14. All right, the last 2 problems are difference quotient problems. And our difference quotient is f of x plus h minus f of x all over h. On 24, the function is f of x equals -8x plus 5. Now, in this section, we talked about if the x is just an x and it's not squared or cubed, your end result is going to be the slope of this line. If I drew this out, it would be a straight line. So my answer is going to be -8. Okay. I am going to work this out using the difference quotient just to get the practice for the next one. Okay. What's the first thing you do when you're using the difference quotient? You're going to rewrite this function, and in place of this x, I'm going to put x plus h. So if I do that, I'll have -8, replace the x with x plus h plus 5. The second thing is I'm going to subtract the actual function, and I need to put that in parentheses, right? So open parentheses, -8x plus 5. So we'll simplify this numerator, and then at the very end, we'll just put it over the h. Okay, I need to remove parentheses, so I'll distribute. So this gives me -8x minus 8h plus 5. Distribute here. That turns that to +8x, and this to -5. And remember what distributing this negative does? It makes everything that was inside this parenthesis do what? Cancel something up front. So let's see, -5 cancels +5, and +8x cancels -8x. So all you're left with is that -8h now over your denominator, which is h, and your h's cancel. So there's your -8. All right, last one. Another difference quotient. But this one I have to work out because x is not just x, it's going to be x squared. So f of x equals 9x squared plus 3x plus 2. Okay, the process is going to be the same. It's just that the numerator is going to be a little more difficult to simplify. I'm going to rewrite the function and replace those x's with x plus h's. So I have 9. Replace the x with x plus h squared plus 3. Replace that x with x plus h. Oops. Plus 2. And then subtract your function. So minus, in parentheses, 9x squared plus 3x plus 2. Now I've got to simplify this. The first thing I need is that x plus h squared. And remember what we did? We FOILed that, right? You probably have that saved somewhere. Remember we talked about saving it so we didn't ever have to FOIL it again. If I did FOIL all this, I'm going to have 9, drop down your 9. This is going to end up being x squared plus 2xh plus h squared. That's what you get when you FOIL that together. I'll just bring down the rest now. Plus 3x plus h plus 2 minus 9x squared plus 3x plus 2. Okay, I probably could have combined a couple of steps here, but all I've done from this step to this step is x plus h squared, FOIL it together. It's always going to give you this. And then I just drop the rest of this down. Okay, now I'm going to remove all the parentheses. So this one I'll have to distribute the 9. Here I'll distribute that 3, and here I'll distribute the negative. So let's see, 9 times x squared gives me 9x squared plus 9 times 2 gives me 18xh plus 9 times h squared gives me 9h squared. Here I'll distribute the 3. So plus 3x plus 3h. Drop down this plus 2. And distribute this negative, which is just going to change all those signs. So this will be negative 9x squared minus 3x minus 2. Now, everything I distributed negative to, all 3 of these terms will help us clean up, right? Because they'll cancel terms up front. This minus 2 cancels the plus 2, minus 3x cancels plus 3x, and minus 9x squared cancels the positive 9x squared. So what is going to be left? You're going to have the 18xh plus 9h squared plus 3h. What's in common with those 3 terms? That you're going to pull out, right, the h, and then it'll cancel the denominator. So if I pull out an h, put in parentheses what's left. If I take the h out of this term, I'll just have 18x. Plus, if I take an h out of this term, I'll just be left with 9h. Plus, if I take the h out of this term, I just have plus 3. And since h is also the denominator, those cancel. So you're just left with 18x plus 9h plus 3. Okay. All right. So that is it for today. So Friday, we will do